Welcome to the Flood Channel. Did you know that a 100-year flood can actually happen as often as every year? And did you know that just because you see someone successfully drive across a flooded road could mean that they're still going to face thousands of dollars in repair bills? And did you know there is a flood control facility built on property owned by the Water District and coordinated with other agencies? You are going to learn about all that and more today on the Flood Channel. Our engineers determined that an existing detention basin located within the property of the Springs Preserve in Las Vegas needed to be expanded. This required coordination and collaboration among a host of agencies, including the Regional Flood Control District, the Springs Preserve, the Las Vegas Valley Water District, the City of Las Vegas, and others, all while ensuring the environment around the area was protected.
A quick history of the Meadows Detention Basin. I believe it was originally designed and built back around 2001. Obviously, since then, there's been a lot of development and growth in Las Vegas, including multiple facilities upstream, detention basins upstream. Back around 2017, it was acknowledged there was some lack of capacity in the detention basin.
This limited capacity highlighted the need for proactive flood control and upgrades at the site to provide sufficient capacity and better manage flows near the Cienega, which is the natural spring system known as the birthplace of Las Vegas.
So early in the design process, the team recognized the real opportunity to improve and protect areas of the Cienega that have been negatively affected by floodwaters for decades.
Traditional engineering solutions for undersized detention basins usually involve more excavation, but at the Springs Preserve, the solution had to be as unique as the environment itself.
Typically, for a regional project, when your basin's too small, what do? You make it bigger. For this one, for one reason you're aware of, neighbors, we couldn't just make it bigger by raising this embankment because these neighbors don't want to see any construction going on in their backyard. Another option is to just dig it deeper, dig it wider. As you can see, there's a beautiful Cienega and trail system from the Springs Preserve that goes through the bottom of this detention basin.
So the project was designed to divert flood flows away from sensitive wildlife habitats to reduce the trash and debris that was being collected in the Cienega and to protect the walking trails that guests use here down at the Springs Preserve in the Cienega portion.
Balancing these infrastructure needs with preservation required several adjustments.
One of the biggest takeaways from this collaboration was the importance of patience, taking the time to listen to stakeholders and moving beyond traditional solutions. That approach helped balance infrastructure needs with environmental and preservation goals and has ultimately led to a better outcome.
Instead of expanding the basin or excavating more volume, the engineers used a peaking bypass channel and a strategically designed spillway that can safely drain stormwater from the detention basin during an extreme storm event without having to change the basin's original footprint.
We removed the existing weir, and as you can see here, there's this zigzagging structure called a labyrinth spillway. Labyrinth spillway increases the effective length of your weir. That total length going back and forth adds up, and now you can spill over, discharge much more flow within the same overall width of a footprint.
This new construction allows smaller, more frequent flows to bypass the basin entirely, keeping trash and debris out of the wildlife areas.
So the initial flow coming into the basin for the smaller storm events comes through the channel and goes right out the outside of the detention basin. Now, once the flow gets greater than that, flow will spill out the sides of the channel along the slope there and fill up the detention basin.
While flood control is the priority, the Springs Preserve's mission of environmental stewardship remains front and center. A creative solution was built into the project that ensures the Cienega's ponds stay filled without wasting drinking water, meaning local wildlife have a steady supply of natural water.
all of that small nuisance flow gets captured and sent directly into the ponds of the Cienega so that hopefully the habitat keeps thriving the way it has been because it's going to keep getting the same water.
Instead of using supplemental irrigation that would draw on drinking water resources, the area utilizes small but consistent flows that are already available in the flood channel to provide necessary irrigation to the area.
This project, expected to be completed in the spring of 2026, demonstrates what's possible when agencies work together to serve both the community and the environment.
It worked very well. Everyone seemed to get their needs met, whether it be the water district protecting the Cienega and not upsetting neighbors, the flood control district getting a detention basin that meets the capacity needs.
The collaboration between the Regional Flood Control District, the City of Las Vegas, and the Springs Preserve really is a strong example of the Springs Preserve mission in action. Creating a visitor experience that builds culture and community, inspires environmental stewardship, and celebrates the vibrant history of the Las Vegas Valley.
Come on.
No. No.
When you hear about a 100-year flood, you might imagine a storm that happens once a century, and then we're good for the remaining 99 years. But that's a common misconception. Here are two local experts to explain why 100-year floods seem to happen so often.
Yeah, so there's a lot of kind of misconceptions about the term 100-year flood. Really what a 100-year flood is just a flood that has a 1% chance of occurring any given year. It doesn't mean it only happens once in 100 years. If you have a 100-year flood this year, it doesn't mean you're safe for the next 99 years. It just has a 1% chance of occurring any given year. And also additionally, it's not even really a flood per se, but a rainfall amount.
Let's think of a roulette wheel. Normally has 39 pockets, but imagine a bigger one that had 100 pockets, numbered from 0 to 99. And you spin that wheel, and in theory, you have 1 in 100 chance of getting 0. So the first spin, you might hit 15. The second spin, you might hit 45. Now, when you spin the wheel again, what number is going to come up? It could be 0 again. You could have back-to-back zeros.
Probability is one thing, prevention is another. For the experts monitoring the valley, a 100-year rainfall event doesn't always result in a 100-year disaster. And it's possible you could have a 100-year rainfall event but not have a flood because the flood control system worked.
Yes, potentially, yeah, exactly. Whether mitigation efforts prevent it or at least make it less severe, because these 100-year flood, these rainfall amounts are pretty significant, so it doesn't necessarily, I would say there's a decent chance that there will be at least some flooding, but due to the mitigation efforts that you guys do, it may not be as severe as it would have been 20, 30 years ago.
The detention basin is built to contain water for a theoretical 1% return interval storm, the 100-year storm. And the basin its main job is to temporarily hold that moisture rather than watching it flow all the way downhill to the developing neighborhood to my left and release the water slowly so that the houses downstream, any businesses downstream, they would not be impacted because they're not getting that wall of water all at once.
The timing of these events is dictated by the seasons. Slow-moving, long-lasting winter storms contrast sharply with summer rainfall that arrives in local, short, intense bursts during monsoon season.
So the winter time, usually we get these big Pacific systems and atmospheric river, and so that usually is a broader, more kind of light to moderate rainfall that we typically see out of those. It also produces mountain snows. But in the monsoon, we get these kind of localized, intense downpours.
But in summer, we tend to have small-scale thunderstorms that only impact maybe a square mile or so. But those are tend to be more intense, so you could have more localized flooding from a thunderstorm occurring in summer.
Every few years, a storm arrives that exceeds even the most extreme flood prediction models. In 2014, the remnants of Hurricane Norbert delivered a surge of moisture that went well beyond the 1% annual probability.
I would say probably in terms of kind of like the most significant and anomalous event would probably be the 2014 Moapa floods. There was a gauge up there that I believe got close to 4.5 inches of rainfall that day. It was actually the amount was closer to a 1,000-year flood. So that was a pretty anomalous event, and we saw what happened, I-15 getting washed out.
Can you imagine getting over 4 inches in a matter of a few hours? That runoff had to go somewhere, and so the surge of water just went flowing down the wash, hit the southbound lanes of I-15 and washed away nearly 2 miles of I-15.
To stay ahead of the next zero on the roulette wheel, the district and the National Weather Service rely on a network of more than 200 rain gauges to provide accurate information about how much rain falls, where it occurs, and how quickly conditions can change.
Your guys' rain gauge network is super beneficial to us. That is something we monitor very closely, and it's nice to provide ground truth to what we're seeing with the radar estimates. And so when we see those rain gauges ticking up and getting up towards 1/2 inch, 1 inch in an hour, then we generally know that there's a decent shot of flash flooding.
Mother Nature is not static, and the world is changing. The climate of the world is changing. So the big question is, with increasing temperatures, does that necessarily mean we're going to see more storms? Are we going to see different intensities with new storms in the future?
In the Las Vegas Valley, the 1% chance storm is certain to occur over time. Protecting people and property from the dangerous power of flooding in the desert is ongoing work, and it never stops. An important part of that work is the district's rain gauge network, which helps keep our community informed. Real-time information is always available on our website, regionalflood.org. Southern Nevada is known for bright neon lights and intense summer heat. But one of our most unique environmental features is the shape and angle of the Las Vegas Valley, best described as a giant, tilted bowl. The shape of our ground can cause stormwater to move quickly, sweeping up debris and waste left on the ground. That is especially noteworthy during the first heavy rain that falls after an extended period without precipitation. This phenomenon is nicknamed the first flush.
When we talk about the first flush, what that means is that in dry periods, pollutants consolidate and increase on paved surfaces and impervious surfaces. And then when it rains, all of that pollutants washes off of those impervious surfaces into the storm drain system all at once.
There's a common misunderstanding about where this water goes. Unlike water from your home, stormwater receives no treatment before it returns to Lake Mead.
We have two separate storm sewer systems in the Las Vegas Valley. We have a sanitary sewer system, that's the sewer that comes from homes and businesses that goes to the wastewater treatment plants. The storm water that falls on the streets and goes into the storm drains ends up going untreated through Las Vegas Wash and into Lake Mead.
The front line of defense against this pollution begins on the hundreds of active construction sites across the valley. Gil Cruz, a water quality specialist with Clark County, spends his days ensuring that builders follow best management practices, or BMPs.
On a construction site, the typical BMPs that we see, they're protecting the storm drain inlets. We want to make sure that they're protected during construction. We also use bumper plates to keep sediment from leaving the site. There's also use of street sweepers and hand sweeping to maintain any debris that does leave the site.
In the desert, protecting against pollution at a construction site is constant work because a storm can hit without warning. Gil explains that the responsibility for this vigilance lies with the contractors.
The construction site is responsible. Obviously, we can't be here every day to inspect a site, so they're responsible to monitor and maintain, and they are supposed to inspect after a rain event themselves to inspect their BMPs, ensure that they're still in service or serviceable, and then replace them or maintain them.
On any active construction site, you can observe the effectiveness of these temporary barriers. While they are vital, they have their limits, specifically designed for what experts call a stormwater quality event. In the Las Vegas Valley, this is also called a 2-year rain event.
This is a wattle, straw wattle, or a fiber roll with sandbags to weigh it down. And the idea is that as stormwater flows to these wattles, the sediment is slowed down and drops out before the water carries over.
It's impossible to try to install temporary BMPs for storm events larger than a 2-year rain event.
So the idea is that these are designed to reduce and minimize the amount of sediment that leaves a site, but not entirely eliminate it.
Right, absolutely. The water has to go somewhere, and to try to keep all of the sediment in is almost impossible. Nothing is 100%, but the attempt to control and retain as much as possible.
Stormwater protection isn't just about dirt and gravel. It's also about containing chemicals and sanitary waste. Even the placement of a portable toilet is a strategic decision.
On these porta potties, we have a couple of BMPs that are in place. We have them secured to keep them from tipping, which is a required BMP for a porta potty. We have containment around all of them for spills from inside. And so we're looking really good. Until I look at the location, the overall location, this project is coming to completion. And so there's not a lot of places to put these, but one of the places that you shouldn't put it is near a storm drain inlet.
This concept of secondary containment, a bucket for the bucket, is a requirement for all liquid materials on a site.
All liquid containers, once they're open, it has to either be stored on secondary containment or under roof. This one is a good example of how your liquid material should be stored when on a construction site.
And the idea, right, is that if you have a spill or a leak of one of these containers, it goes into that secondary containment unit rather than onto the soil and eventually draining off the site.
Some BMPs serve dual purposes, protecting both the water and the very air we breathe.
So one example is this rumble box behind you that is used to reduce the amount of track out from a construction site. That's an air quality benefit and a stormwater benefit, because the air quality benefit is that it's not creating dust as vehicles travel on the paved roads and kick up that sediment and create dust storms. But it also helps reduce the amount of sediment that ends up on the paved roads that can be carried into waterways when it storms.
As trucks leave the site clean, it reduces the amount of sediment that could eventually be washed into a storm drain miles away. While physical barriers like wattles and rumble boxes are important, both John and Gil agree that the most powerful tool for environmental mitigation is a well-informed workforce.
During the course of a stormwater inspection, I'm responsible to ensure that they have their BMPs in place and to educate them, to educate the superintendent, the site superintendent, the project manager, the construction company on site. We found that the best BMP is education.
For more information on the next contractor training, visit Regional Flood and search Stormwater Training. Protecting our water supply is a marathon, not a sprint. It requires constant maintenance, site inspections, and a commitment to keeping our stormwater as clean as possible.
Let's go, come on! Don't you do it. It's just a little water in the road. The light is green, there's places to go. It's just a little water in the road. The flash flood grows, how deep, who knows? The other cars made it. Watch and learn, let me show you how it goes. Loco!
Ooh la la!
Yep.
You often hear us say, turn around, don't drown. That driving through floodwater is never worth the risk. We're here today at Jim Marsh Kia to talk about just how expensive some of those consequences could be. The question is, for people who might see videos on social media of cars that successfully cross a flooded road, they might see that and think, oh, I could do that too. Can you talk about some of the damage you've seen from cars that might have been invisible when it first occurred, but then became a problem.
Yeah. Interior, there's computers under the seats, there's wiring, and corrosion takes time sometimes before it affects circuits. So you can go through the water in 6 months, have tons of green corrosion and not know it, and then all of a sudden you start getting lights, check engine lights or whatever it may be, or it could be anything.
One thing to remember is that floodwaters are always dirty, dangerous, and you don't want to be driving in them. It only takes about 12 inches of floodwater to move a vehicle. That's not very much water. So we highly recommend not driving through floodwaters. Even though the vehicle in front of you may have made it through safely, you have no idea how much damage has been done to their vehicle when they drive through that.
Water's being intruded into the engine because people think that they can go through water even though it's not deep. You can still ingest it into the engine. It's not a difficult thing to do. And then deep water, getting into like say a hybrid batteries, the high voltage wires go all along the bottom of the entire car. That's not deep water, you know what I mean? It doesn't take much. But yeah, I've seen everything. Full interiors being replaced, everything. It's not a wise idea.
So it could take up to a year, you're saying, for the damage to fully appear?
It could take for a while depending on where it is. If water gets into the kick panel, for instance, there's a lot of connectors in there, and that's where most of the problems will happen. And you can see the damage by rust and whatnot under the seats. So you can tell that the car was in a flood, and then of course the customers usually, it was so long ago, they're like, oh, I don't remember or whatever, but the evidence is there.
Here in the desert, we have some unique features that make flooding behave differently than it does in, say, California or the East Coast. So what's the most common type of flood damage you've seen on cars here in Southern Nevada over the years?
Water intrusion into the engine, seizing engines, car just stops. That's the most common thing. That and, like I said, carpet being wet, and the computers under the seats, the wiring in the kick panels, or the floor harness. You got a whole floor harness, airbag wire. There's a lot of stuff in there, you know. But I think a lot of engines.
Can mold be an issue?
Yes, yeah. That's one of the things. If it gets so bad that your whole carpet's wet, you're gonna get mildew and it's gonna stink. You're gonna have to replace the carpet, everything. But the bigger portion is the wiring that's in these cars. The whole floor, there's wires everywhere.
That's a double whammy. You end up with a stinky car interior. We'd have to have the entire floor replaced to fix it. And on top of that, your electrical system is going to have nightmares over the long term from that one decision to try to drive across a flooded road.
Right, it's not worth it.
So this much water on the ground could splash up and cause a big issue in this part of the vehicle.
Right, yeah, lots of variables, but yes. This is an air box. This is where it's manufactured to pull air from, but it doesn't take much to get water into the other components. Honestly, this isn't really sealed. There's a seal here, but that's not going to stop a bunch of water. Plus you have air being pulled into the engine constantly, so it's like a vacuum. You just ingest water. If you get it into this box at all, which is, about yay high, directly right into the motor, it just all depends on how fast you're pushing the water and if the water can get up in there. When you're going through deep water, not even deep water, you're just going through water, your car is pushing it. If it's up to the bumper, you're forcing it, you're making a wave, which is not good because it's got nowhere else to go but back, right? I mean, they're cars, they're not boats, Just don't drive in the water. It doesn't take much.
So whether you drive a gas only or a hybrid or electric, it's just bad news to drive through floodwater.
I would think the electric would be probably a little bit more scary, but this is the high voltage wiring. It is sealed, but you do have connectors like on the battery, which should have weather packs, but it doesn't mean that you're not going to get it. It's not going to get wet, but it should be dry. But this is the kind of stuff where the wires are under a cover, goes into the trunk. So if you were getting into the water deep enough to where it got into the trunk where the battery is, that's money. There was a guy who would buy cars from the auction, and he thought he was getting a great deal, so he bought several, it was Sonata hybrids, and he bring them in saying the cars wouldn't start. So we start, like every car, you look at it, you push it in, you open the trunk and to see what's going on because the battery's in the trunk, and there's just flood damage everywhere, including the hybrid battery. I mean, everything, everywhere we looked in the car, under the seats, everything was rusty. The seat pans, the wiring, everything was corroded. Just, it was gone, completely gone.
So it's not worth the risk. We remind people always to make smart choices when it comes to floodwater. Turn around, don't drown. We've all heard it for years, but it's really true. It's a very catchy slogan. Make the smart choice, go to a safe place, grab a cup of coffee, go do some grocery shopping, wait out the flood. We're very fortunate here in southern Nevada because the storms don't last that long. So make the smart decision and wait it out.
And you just named, so there's the damage to carpeting, there's the interior damage, there's the engine damage. What kind of a price tag are we looking at for that typical repair?
Total car. Engines, $8 grand, $9 grand to replace an engine. But if it's all, I mean, it's total. The car's total, you know? It's not cheap. Like floor harnesses are several thousands of dollars, and you're talking 8-9 hours. You got to rip apart the whole entire interior to get to it. Not just the floor, the side panels, because the wiring goes up into the pillars. It goes everywhere. It's a big job.
Just from a few seconds of deciding, I'm going to save 5 minutes off my drive time, I'm in a hurry,
Exactly.
and across this flooded road, can lead to the vehicle being totaled.
Yeah.
Wow.
Absolutely.
So let's say you've got like 30 seconds to talk to someone about this, and they tell you, hey Corey, I'm thinking about driving my vehicle through that flooded road.
Yeah.
What do you say to them?
Don't. It's not worth it. It's just not worth it. Turn around. You know, I mean, you see cars floating, and people think it's not deep. It's just not worth it. It's not. It's expensive. You get caught.
Thank you to Corey and the team at Jim Marsh Kia for taking time to talk about the risks of driving through floodwater. This is a powerful reminder of just how much damage floodwater can do. It might be tempting to try to rush across a flooded road if you're in a hurry, but it's never worth the risk. Water always wins. Thank you for joining us for this episode of The Flood Channel. You can always learn more about the Regional Flood Control District at regionalflood.org. And you're invited to follow us on social media, X, Facebook, Instagram, or TikTok. @Regional Flood is our username. We'll see you next time.